Hello! Let's discuss our lobby system for this. What a lobby generally is, from 10,000 feet, and I'm sure there's more to be said about it than this, is a system by which players can organize and prepare their connections for the actual game. We will be supporting two different networking systems here. ENet, which is free and open source and Libre, which I love, and works directly with sockets. And a socket is just an IP address followed by a port. That's all it needs. And Steam, which is a relay server which heavily relies on its own definition of a lobby. We will be implementing the same game using both, starting with ENet and then progressing to Steam. You will remember the Steam Init and Steam process callbacks functions we've got in there. They are important here, though I don't intend to come back to them again in this video. Now, what do we have here? We have a VBox, keeping everything vertically aligned. I want the same player name available to both. The default is the Warrior here, which was the older version of this program, but it will be replaced by your Steam Persona name here. And to be clear, this demo program will require Steam to be running in this form. The tab container simply uses tabs that take the name of the components that are childed to it, in this case ENet and Steam. I'm sure there's a way to override that, but it works great for us for now. And under ENet, along with some organization material here, so that it remains perfectly visible on all possible displays, we have one label that simply describes what this pane is, a host button, a join button, an IP address to join, and a start game button. Ideally, you might also have some feedback field here that tells you how many players are connected, but I'm trying very hard to keep this simple for the sake of its communicability. So let's move forward into our script. We'll come back to Steam momentarily when we get to that. When I'm going to be shuffling nodes around, such as when I'm not entirely sure that I'm satisfied with how they've been placed, I will typically export them. Otherwise, it's perfectly acceptable to use onReady here and simply give it a direct path if you know that path isn't going to change. And if we click on Lobby and look at these exported fields, they're all set to what they're going to be referring to in the scene graph. The connect button for Steam, the players list for Steam, the error label, player name. I can shuffle them around now, and as long as I haven't changed any of this code, it'll be just fine over here. You do want to make sure that none of them are empty or null, though. I have one signal I have in here I've added, which I like to use because sometimes you have a lot of things being printed out which are just for your own benefit. And sometimes they might actually contain data which might be indicative of a networking or program problem, which you might want to be submitted. So it can be helpful to send all of your print statements into a log, which is attached to a signal, and pipe that signal to whatever function you want to write your log file, or just print it to the console, or play some loud annoying sound, whatever you want to do. The idea is this keeps us loose and flexible. Not that I'm beyond still dropping a print statement in there now and then when something's just acting weird and I want to figure out why. Moving forward, though, ready is the first function called in these nodes other than enter tree, which we're not going to worry about here. First thing it does is it takes persona name, and sets it to Steam's get persona name. This is the text that you use to identify yourself as on Steam. In my case, it's Vitruvian stick figure right now, and it's actually quite flexible. It's not what Steam serializes your player by. That would be your Steam ID, and by good design, you should never actually have to look at that. In fact, this is true of most serials. The only thing you need to worry about is that they're unique, and the only time you need to actually see what they are is if you are actually doing a visual inspection when going over your code and debugging it. Moving forward, We have our connections from game state. I'm going to jump into that file for just a moment because we created these. We'll be coming back to this in a moment. These signals are player list changed, connection failed, connection succeeded, game ended, game error, and of course I have another local game log. We'll come back to their implementation, but they basically self-describe. Not that that is a proper excuse for not documenting your software, guys. It's very important that everybody's on the same page. But I do want you to understand that these are fired when a connection is detected as having failed, a connection has succeeded, and then it triggers behavior that's appropriate to that. But it's all set up in lobby, because lobby is the first thing to interface with game state, and it's how we set it up. I like to use lambdas for these instead of sending people on wild goose chases for other functions, because I find it to be, once again, more communicative. If a connection fails, Steam host.disabled is equal to false. In other words, it's enabled, so you can start over. And the error label describes as much, and that's all we really need to worry about there. It might be a possibility later to worry about a specific kind of failure, but that's actually not as common as you would think. Valve does a great job with this stuff. ENet is a very solid piece of software. Connection succeeded. It hides the Steam Connect and Steam Players as shown. Now, this is of course generally orienting around the Steam lobby. Player list changed is something that I wanted to call from somewhere else, so in this case it's not a lambda. We go to refresh lobby for that. Oh, where did I put you? Here we go. First thing that does is get our player list values, sorts them, grabs the list underneath Steam Players. This is a line I'm not entirely sure about because it means I can't rename list, but it's functioning for now. And iterates over all of the names in players. Then adds an item to that lobby list. This is basically a list of all of the people on that lobby over Steam, which we will return to perhaps in the next video when I connect with Steam using a different computer. Lastly, I have a little bit of ternary logic here. To add you after your own name. It looks a little complicated, but it's brief and it won't break anything, so I left it in. Lastly, the start button for Steam is set to a value that will be true if you are the host, but false for everyone else. The host decides when to start this game. You may have different logic in mind for your own creation, but this is what I'm establishing now for this one. After that, we have an await function here. It's not uncommon to wait maybe a second or so for this as a reasonable amount of time, but I don't encourage that when there's another signal available. We're waiting for lobby to be joined, and Steam emits the lobby joined signal when that lobby has been joined. In many places, this will take far less than a second. In some places, or given unusual network conditions, it could potentially take much longer, so waiting for a second is not always enough. After that, we have a little bit of feedback to us with a lobby ID. Now again, that's a serialized number. I just want to demonstrate something with it, which takes that lobby ID, stringifies it, and applies it to that lobby ID text, and then calls request lobby list. We'll come back to that in just a moment. So that's what that does. If the game state ends, then we call these functions, which basically just bring us back to this page. That is very much dependent on this particular program. You are likely to have something quite different on yours. But if there's an error, we will show a dialog, which is popped up and centered, and it once again disables the host button. I think that's a good idea. You don't want it enabled until you're ready to go again. And lastly, we've got our game log here. This could once again be a log file, or it could be piped over the internet somewhere. There are a lot of things you could do. The whole reason it's a signal is to keep it flexible. After that, this is just something I added here. You could put anything else you wanted in there. But the player name itself, what you're going to be identified as in the game, is set to your persona name by default. This is a line edit field, a text field, so you can change it if you want to. And lastly, we've got one more log function set up here. I'm not entirely comfortable with repeating code here, but it's 2 lines and it's readable, and that's the most important thing at the moment. Lastly, it sets up the user interface. So let's take a look at that. The first thing Steam calls is add request lobby list distance filter, which is a mouthful, but it's a very handy function. When you request a list of lobbies from Steam, you can use this to determine how they are organized. Lobby distance filter close is what I usually default to. There are a number of others as well. And that will basically pipe it to you in a list where one end of it is going to be much closer than the others. You could also go by... Actually, I'm not going to speculate on that because there are a number of different options, but they're all very well documented and it's quite functional. Now we have Steam's lobby match list signal. This is not one we created. This is what happens after we request that list, which makes it very useful to us. It takes as a parameter an array of lobbies. So we go over each lobby as sample here. We're sampling from the lobbies. And then use Steam's getLobbyData function to look for a name value. Now, getLobbyData and setLobbyData are basically dictionaries attached to a lobby ID. You can put pretty much whatever data you want in there. And as a caveat, if you look up a value that actually is not defined, you're going to get a blank string back in turn. Then we have getNumLobbyMembers. That could have gone into lobby data, but it's common enough that it's got its own function. Taking the lobby ID again, remember that's what sample is. And it stores these things in fields. Now, what we're going to be using them on is the text on a join button for it. Set text string lobby name colon member count joined. So you get the name of the lobby if it has one defined, and the number of members, which it should have defined. Then we set a basic size for it here. This is just something I'm comfortable with. It's relatively arbitrary. The lobby container then has a child added of this join button. But you know, we're not really done yet because the join button is not actually attached to anything. We need to connect its pressed signal. And we'll do that here with another lambda. What that does, when you click on the button for this particular lobby, it hides the Steam Connect, shows Steam players, which is all the players connected to your Steam lobby. And to clarify, if we jump over to Steam here, this is Connect, this is players. It should only really show one at a time, so that's what we're doing for now. Since you joined technically a lobby, and the lobby, I remind you, is not the same as the game. We'll come back to that when we get the game state. Then we call GameState's joinLobby function, using that lobby ID, which is what sample is, and your player name. I'm going to jump over to GameState again here to demonstrate this, as I think it's important here. Let's jump down to joinLobby. To summarize what this does, it sets your local player name to be the new player name passed in. So it's kind of a slightly convoluted way of passing in your text field to be what you want your player called in the middle of the game. You may have all kinds of things here. You might even have a full Saints Row style character customizer that needs to be passed in. But what you need to be sure of is that it's synchronized across all players. which is where a lot of this stuff comes in. Then we call Steam join lobby with the lobby ID. What happens in there, I have no idea, but it's very effective. Basically, it notifies Steam that you are joining that lobby, and Steam already knows your Steam ID, so you don't need to pass that in. And that would be the end of that particular connection function. Lastly, it calls request lobby list. What does that do? Well, the first thing it does is it clears out every child in lobby container, just in case we are just refreshing it, and we already have a bunch in there. Then we call steam.requestLobbyList. What does requestLobbyList do? Well, after it's been called, you get the lobby match list callback, and all of this happens. Now, on host pressed is related. It hides connect and shows players, just like joining did. Then we go to game state host lobby with player name.text passed in. We don't need a lobby ID because we don't have one yet. Host lobby once again sets your player name to that text that you are passing in. Since you would be the host here, or the server, and that peer ID is always 1, it also updates our dictionary of players to set 1, or the host, to equal your player name. I don't like to record things more than once in fields. I find that's a recipe for bugs. But generally your players list, or dictionary, should be a dictionary of peer IDs to whatever kind of unique data you want associated with that player, including the ID. But you might have other material on there too. Maybe they have something they bought in an in-game shop that they're bringing in. I don't know. For the moment, I'm keeping it simple with just the name. Now, create lobby is interesting, as there are 2 parameters to it. In fact, let's go over them using autocomplete. Invisible is mostly for testing. Public and friends only are the 2 most commonly used. We also have private and private unique. I unfortunately do not have these descriptions in front of me. You can use any of the 5, but it will determine how your lobby, or whether your lobby, appears to other people searching for it. This is a great place to look based on how you want people to be connecting over your game. Do you want it to be mostly between friends? Is it going to be a long thing? Or are they just looking for quick action matches? Max peers is set to 12, which was the default here from the first version of it. I think it's way too many people for a Bomberman clone, but it gets the idea across. The highest I believe you can go with Steam is actually 250. As of the moment, anyway. I could be wrong on that. You might look it up. But that's 250 concurrent peers, and there are a lot of stresses with having that many because they're all constantly trying to update. Somebody gets a little network congestion, or you're too far apart, it can be a pretty big problem. I try and keep this reasonably small for the sake of ping rate. But, I'm getting a little sidetracked now. We've gone over host lobby. There's create lobby there and join lobby here. Tied by the Steam ID of the lobby. Then we have refresh lobby, which simply gives you once again, the players that are in that lobby. When somebody joins, they should show up after a brief pause in there. Refresh player count is something I was going to add for ENet, but decided not to. Now, on start pressed is what happens when a start button is pressed, and that just calls GameState.BeginGame. Before we go over that, though, let's look over our ENet stuff, because I said I wanted to do that first, and that's the case. So on host pressing, ENet hosts are a little different from Steam hosts. They're usually the first kind of thing people learn. They use sockets, not lobbies. You can create a lobby for them. but generally that involves running your own service for the game too, getting a server set up. Um, it's something that I personally find to be easier to allow a dedicated service like Steam to do. But it's important to have ENet as well because, maybe someday you will end up working with a different service too, or you will want people to be able to play it without having a Steam account. This is all perfectly valid as an objection. So, create ENet host. Just be close to the bottom. First thing it does is it sets your multiplayer peer to an ENet multiplayer peer, and then calls create server on that ENet multiplayer peer, which does just what it says. It takes a default port, which can be anything you want, maybe even something flexible. I just suggest keeping it above 2000, as everything below that is generally reserved. Sets your player name, adds you once again as peer 1 to the players list, and then finally sets the multiplayer peer to be this ENet peer that you just created. ENet comes with stock Godot. Steam multiplayer peer, on the other hand, and we'll come back to this in a bit, requires both Godot Steam and the Steam multiplayer peer extension. Now, creating an ENet client is very similar to this. You're once again creating a new peer, then calling create client with an address in the default port. I remind you that these two together make up a socket. If it's an IP address and a port and it attaches to anything at all, that's called a socket. A socket. Which is fundamentally how many other networking systems work too, but they insulate you from a lot of this. You set multiplayer's multiplayer peer to it. Then we have another await here. This awaits connection to the server. It's another case where people will often try and wait for a second or two to just make sure everything works out. It'll tell you when it works out, man. Just do multiplayer.connected to server. That will be fired at that exact moment within reason. After that, we have a remote procedure call with our new player name to register player. I will come back to that with game state when we return to it. But what it effectively does is it ensures that everybody has this connecting player in their list of active players, which is important for synchronization and also important for dodging a potentially serious bugs involving, say, in this case, score incrementation. Lastly, players multiplayer.getUniqueID will get you your peer ID. Now, that's once again a serial. I don't really care what it is as long as it's as unique as it needs to be. It may be very different between ENet and Steam. In fact, for all I know, it is your Steam ID. I don't encourage just using the Steam ID because there's no guarantee there that it's always going to be the same. Unique ID has everything you're after, and sets that to your player name. So, one for the host, and something else that's already been generated for you for all of the other peers. Again, you'll note that all ENet join press does is set your player name for game state to the text field here, then calls create ENet client, which I just went over. And lastly, if you have the address for the game under ENet, this guy right here, IP address to join empty, it's always good to default to the local host. If you don't know what the local host is, that is the exact machine you're working on. Default IP address is 127.0.0.1. So it attempts that if it's empty. Otherwise, it goes with whatever's in that text field. So if you happen to be using multiple machines on the same local area network, and you know the IP address of one of them, you would type that in instead. I don't want to spend too much time on that, so I'm defaulting to using it on this machine. I believe that is our lobby code. The great thing about ENet is you can actually test it on the local machine. You can't do that with Steam. Steam requires two separate Steam IDs for understandable reasons. The great news is, with multiplayer peer being a basic facade pattern, we don't need to worry about how it is that we're connected so much as that we are connected. Now, this is wonderful when you're attempting to support multiple services. You want to throw it on Switch later, that is a godsend. Or Epic, or whatever else we're going to be doing. Alright, so that was the basic ENet connection, and I will see you in the next one for Steam connections.